Alright, so there are two basic types of waves. There are deep water waves and there are shallow water waves. Now, contrary to what you may think, a deep water wave does not necessarily mean that it is in deep water. In fact, a deep water wave can be in as shallow as water as less than a foot. Um, Also, shallow water waves can be in water deeper than thousands of meters. Instead of it being dependent on how deep the water is that it's traveling in, it's actually dependent on the ratio between the wavelength and the depth of water. So for a deep water wave, that's defined as a wave that is traveling in water that is deeper than 1/2 of its wavelength. And a shallow water wave is defined as one that is traveling in water that is shallower than 1/20th of its wavelength. So what you'll see is that there's a pretty big discrepancy between the two, tenfold as a matter of fact. But that's not a problem. We're not going to split hairs on it. All the waves that are in between that zone are transitional waves, and they have characteristics of both types. So it gets really complicated when you start looking at transitional waves. And transitional waves, there's a lot of them. There's a lot of depths out there. But what we're going to do is just look at the end members so we can get an idea how each one of those work, and then you'll just have to accept that transitional waves can have characteristics of both.